Okay, so today your job is to make graphs out of these parent functions. This is the baby function for the parent, y equals x squared. So the first thing I do is I identify where is my new vertex going to be. And the plus 1 moves it to the left 1. The minus 3 moves it down 3. So I'm going to go left 1, down 3, and put my first dot. That's my new 0, 0. So when I make my t-chart, I won't need to put 0, 0 because that's it right there. Then I plug in some numbers for x, and then I just square them. Why don't I use the plus 1 or the minus 3, you ask? And that's because I already did the left 1 and the down 3. So then you just plug it into x squared only. 1 squared is 1. 2 squared is 4. 3 squared is 9. So from this point, you're going to create these ordered pairs. You're going to go 1, 1, 2, 4, 3, 9 is slightly off the graph, but you still know it's there. And then I didn't plug any negatives in, but I do know it does make a parabola, and I should be able to reflect those points as well. 1, 1, 2, 4, and 3, 9. Oh, I'm sorry, this was not supposed to be that squiggly. It's just tough to draw on this little Mobi board. Anyway, that's what the quadratic graph looks like, hopefully a little more curvy than mine. This one, exact same problem, except it has an absolute value. Absolute value bars make a V. So we're still going to do the first dot. It goes to the right 1 and down 3. Right 1, down 3, put your first dot, and then you're going to make your parent function t-chart. The t-chart, you just take off the 1 and the 3, and you just do the absolute value of x. Plug in 1, 2, 3 again. What's the absolute value of 1? It should be 1. Absolute value of 2 is 2, and 3 is 3. So we're going to go 1, 1. Starts out the same way as the quadratic. However, it goes straight lines. I had a question the other day that says, well, why does it go up? And the reason it goes up is because the absolute value makes the output always positive. So that's why this part here is going up instead of down. Because if it was going down, it would have made a straight line. And we know it's not a straight line, it should make a V shape. Okay? And the third one I want to do is that greatest integer function. You may have noticed a poster in my classroom of the greatest integer function, but what it does is just make staircases. It's a staircase. So I'm going to start by moving left 2 and up 3. My first dot is going to be left 2 and up 3. That's my first dot. And then I could make a t-chart for this, but when I plug in 1, I get the output of 1. The greatest integer works like this. It's the greatest integer less than or equal to your input. So if I plug in 2, I get the output 2. Okay. If I plug in 2.5, so let me go over 2.5. 1, 2.5. The output is the greatest integer less than or equal to 2. And so that, or less than or equal to 2.5. And the output is 2. And then I could do 2.9. Well, is the answer still 2? 2.99 still 2. But it's when I get to 3, I put an open circle here and it jumps up to 3. So basically it makes a bunch of straight lines across until it gets to that next integer. That next integer, you put an open circle. Make sure that's a good line. Open circle and it jumps up. So see this one? It goes straight across, open circle, it jumps up. Make a dot. So it's going to be follow a linear pattern and it has an open circle. So I get the question a lot. Does it always have an open circle on the right? Well, no, you can still translate this. You can reflect it. You can make a staircase going down. But the only way you'd have the open circle backwards is if you had a negative on this x. And we're not going to see a lot of that right away. We're going to learn how to do just the basics first. Okay, I'm going to go ahead and pause this video and I'm going to do these next 3 problems over here. So if you want to practice doing them, that would be great. I'm just going to pause it, do the problems, and then unpause. So go ahead and pause. Okay, so hopefully you unpaused now. And there's the first 2 problems. Here's this third problem. I'm going to show you the rational function because it's a little weird. So I moved to the right 1 and up 2. Right 1 and up 2. Now instead of putting a dot, I'm going to put a plus sign. Because if you notice on the parent function picture in my classroom, 0, 0 is not a point. So this plus sign represents the new starting point, the new origin, 0, 0. Okay, and then from there, I'm going to plug in 1. 1 over 1 is 1. So go 1, 1. Plug in 2. 1 over 2 is 1/2. Plug in 3 is 1/3. 4 is 1/4. And it goes like that forever. Keeps getting closer and closer to the axis, okay? So then if you go backwards, you can plug in a 0.5. Well, 1 over 0.5 is actually 2. Then if you plug in 0.3 or 1, like 0.3 repeating, 1/3, you get 3. Plug in 1/4, you get 4. Plug in 1/5, you get 5. So it makes the function go up like that. And then it does the same thing for negatives. -1, -1. -2, -half. -3, -3rd, and so on. So that's why we get 2 different curves. And the reason is you can't plug in 0 into this because 1 divided by 0 does not exist. There you go. And hopefully you should be able to knock out most of those parent functions on your assignment today, and good luck.